Greetings and salutations. Welcome to another video. This one was suggested by a viewer. I mentioned Anacron in a recent video, and somebody posted that they would like to see a video about Anacron. I answered them by saying that I had posted a video about Anacron years ago, but I would take a look at it and see whether it was worth an update. I did take a look at it. I don't like my original video. I think that I'm telling you to do a lot of things that you don't need to do to get Anacron to run. So we're going to address that in this video. Also, I was under the impression that Anacron was kind of sort of deprecated these days because of System D. There's probably a couple of neckbeards out there right now who are typing furiously in the comments section asking me why I am doing this video. Like, Anacron? It's ancient. System D does all of this these days. Well, apparently, Anacron is alive and well and considered to be a very important part of the Linux system and should be supported ad infinitum. It ships running on every distribution of Linux out there because it's a standard part of the system. And I looked at setting up timers in System D, and I found it to be way more difficult, especially for a new user, than just writing a simple script and putting it in the right directory to run on Anacron. System D requires you to write two separate files, and those files have their own language and their own layout, and so you have to know exactly how that works. Whereas with Anacron, you just write a script, and yes, there are some considerations. We have to write it in a certain way, but it's a simple bash script, and we run it, and it just does what we need it to do. No problem. So this is actually an easier way to do this. Before we jump into it, let me ask kindly that if you like what you see, that you give the video a thumbs up. That helps YouTube put videos like this in front of more people because it lets them know that people like them. And if you are not currently subscribed to my channel, please consider doing so. That helps me. Before we get into Anacron, there are a few things that we need to cover first, especially for those of you who are brand new to Linux, just starting out your journey. The first thing that we need to talk about is writing a script and how you do that. I can show you how to do that in 3 minutes. I'm going to show you how to write a script that will run, and it works, and it's really not that hard to do. So the first thing we need to do is open up a text editor. You can use any one that you like. I'm going to use Nano. And the first thing that we need to put in a script is the shebang. The shebang tells the system that this is a script, and it tells it where to get the command line interpreter it's going to need to run the commands that we put in the script afterwards. In this case, we're using bash, but this pretty much works the same way if it's Python or Perl, anything like that. So a shebang is quite simple. It starts out with a pound or a hashtag, if you want to call it that, and I typed the wrong thing there, an exclamation point. So that's your bang part of the whole deal. And then we tell it where the command line interpreter is. The standard way to do this is to do bin bash. That is a standard shebang, and that's the kind of shebang we're going to be using. Now, I know some of you guys out there, you're into scripting, and you know that there are different ways to do that. Don't start writing a comment yet. We're going to get into that later in the video, and I'm going to tell you why I'm doing it this way so that you understand. The main reason is compatibility, because any other way of doing this, while it may work, may not be universally compatible on every system. So that's why I'm showing it this way, and that's why you should write your scripts this way, because you never know what system it's going to end up on, where you're going to go, or maybe you want to give it to your friend or whatever. So we want to make sure that we're compatible, and this will make sure that it works the way it should. So that's the first line. The next line of a script is usually some sort of a comment. We want to explain what the script is so that when we open it up, we have some idea of what we're doing. And this is very important if you start writing long scripts. You need to put lots of comments in. Pretty much every command that you put in, you need to explain what it is doing And the reason is because if you go back and look at it 6 months later after you wrote it, you might not remember what the commands do. So give yourself a lot of information there. And we put a comment in by using another pound. Everything in the script that has a pound in front of it except the shebang, the system is going to look at that as it's parsing through it, and it's going to see that that's there, and it will know that any text after that on that line is nothing but a comment, and it won't bother with it. So just put something there. This is my first script, and we're going to go down to a new line. And don't worry about leaving the white space between the lines. It doesn't slow the script down or anything. The system just skips past that. I like to leave a lot of space in my scripts just so you can see it, so things are open and they breathe and it's easy to figure out what's going on. If you cram everything together just for the, conserve space or whatever, then it makes it harder to read later. So we're actually going to run a command, and this one is going to be echo. And we're going to do what every computer programming class in the world usually starts out with, and that is the hello world script, or just getting it to print on the screen. And we'll put it in quotations. We don't necessarily have to put it in quotations, but we're going to do it here. And I usually like to end my scripts with an exit command, although that kind of bit me later on, and I'll show you in the later parts of the video when we get into actually writing Anacron scripts. You don't necessarily need it there, but I like to stick an exit at the end so it just ends the program. That's all it is. It's a very graceful way to get out of a script, and the exit command with no argument will simply close down the environment that it's running in, and then it will echo the error code from the command that ran in front of it. So if there's an error, it will put it in the correct place in the variable that holds the error codes, or it will exit with an error code of 0, which means that there were no arrows. I live very close to a fire station. I'm sure you can hear that. Apparently they're going out on a run. So our script is done, and to save it, Control O, and we'll give it the name hello.sh. A free-floating script, one that is not in a particular place on your system to run all the time, usually does not have any extension like sh, or rather it will have an extension. Commands that are placed in where you're going to run them all the time usually do not have an extension, but since this is a free-floating script and we're not putting it in any particular directory to become part of the executable path, we put an sh on the end so we can find it later. The system doesn't need it. This is for you. So I hope it didn't confuse you there. Because it is a free-floating script, it's going to have this sh. We're done. We have put our script in there, and we're not quite ready to run it yet. We can check to see that it's there, and yes, it's there. But if we list that and we put the long option, you'll see that the permissions here do not include the ability to execute. And we need to be able to execute this as a program in order to see if it works. That's super easy to do. We're going to use change mode. There's no E on the command. And to set the permissions, we're going to do 755. 7 means that you can execute, read, and write. So that would be me. I get 100% privileges. And then we're going to let people in the group execute and read it. So that would be a 5. And then anybody else who can run the script anywhere else in the world, if they get access to it, they are going to be able to read and execute the script. So let's see if that does what we want it to. Got to give it the name. And we will rerun that list to see what took. And there we go. You can see that we got exactly what we were looking for. I can read, write, execute, and read, write, and execute the script. People in the group can read and execute, and anybody out there can read and execute. We're not giving anybody the ability to write. Read is 4, write is 2, execute is 1, and so that's how the numerals work. So you could actually completely make it so somebody can't do it. If you put zeros in there, you're not setting any permissions. You can lock yourself out from your own file that way. And there are ways to get rid of that. You can force it to delete, but that's something that's kind of fun to play with. Okay, so let's go ahead and run it. We cleared the screen with Control L, and we can run our script. But if we just type in hello world, the system's not going to know where it is. And the reason why is the system looks for executable code in certain places. This is called a path. How do we see the path? It's super easy. Echo, and then the path variable is a $, and capital path. So if I echo this on the screen, it should show us where all of our programs can live. If you're going to be doing a lot of scripting, I would suggest that you create a bin directory in your own directory, and you can put your personal scripts in there. And then the system will look there first before it runs anything else. And nobody else on the system should have access to it. If you're going to do scripts that are going to be run by the entire, all the users on the system, then you put them in user local bin. So those are the 2 places that you put scripts that you create yourself. All right, so how do I get this to run? Well, I need to tell the system where it is. So I am going to use the dot, which represents the current directory, a / and the name of our script. And now we should be able to run it. It worked! We echoed hello world. Do you see that? Isn't that cool? We wrote a script. It's that simple. It's really not that hard. So let's go ahead and clear that out now that we have the basics of scripting. Have fun with that. What Anacron does is it will run a task that we give it periodically. And this is different from what cron does. You may know what cron is. We're going to take a look at that on the system as well. We'll talk about how that works. Anacron works with cron. So to find out where all of this lives, we're going to cd the etc directory, etc. This is where all of the settings for the system usually live. And that's called etc, etc, or etc, whatever you want to. We're going to go into there, and I'm going to list everything that starts with the word cron, and we'll put a glob or a star there, whatever you want to call it. And what this is going to do is it's just going to list everything that starts with cron, and if it's a directory, it will show us what's in it. So watch. So the first thing we see is that we have cron tab. This works with cron. This is where you would set system-wide cron jobs. And then we have cron D. What this does is it's where programs can set up tasks to run, and they will throw them in this directory. So you'll notice here that we have E2 scrub. That checks the file system. And then we have the Anacron cron tab right there. That is where the Anacron system starts. This is how it runs. It runs Anacron here, and then it goes and looks in these directories for jobs to do. And you will also see here that we have Timeshift hourly, and what that does is tells the Timeshift utility once an hour to go check and see whether it needs to do a system backup. We've talked a lot about Timeshift. It's one of my favorite programs, and it's been in the last couple of videos. Essentially what it does is it creates these system snapshots, so if you mess something up, you can roll back. We'll take a look at it at the end of the video to see how it ties in with all of this scheduling tasks things. We'll show you how Timeshift actually does that. Back to Anacron. You will see that we have cron daily. This is a directory. cron hourly, cron weekly, and cron yearly, which is rather ambitious if you stop and think about it. If you're going to put a job in cron yearly, that's something that's going to run once a year, you are very confident that this system is going to be up and running for a long, long time. You know what I mean? We're mainly concerned with cron daily, cron monthly, and cron weekly here. We're not going to worry with hourly because we can just set up a cron tab to do that. And that's an entirely different system with a totally different syntax. It's not terribly difficult, but we're going to just use cron to start Anacron in this video, and we'll just leave it at that because honestly, most of the people watching this video, you would probably prefer to use Anacron to do what you need to do anyway because of the advantages. Cron does things on a schedule. Now you can tell cron to do something at 2:30 p.m. every Thursday. You can tell cron to do something on the 5th day of the month every month at a certain time. The problem with cron is if the system is not up and running when that task comes up, it just doesn't get done. So for a monthly thing, that could very well mean that that doesn't run for 2 months if that system is down. Anacron goes and checks to see whether it has run all of the tasks in these directories, and it looks at the date, and if it says, I haven't run that, even if the system was down when it was supposed to have run, it'll go ahead and run it. It'll catch up. So if you leave your computer off for a week or close your laptop and forget about it for a couple days, anything you have scheduled to run in the background, it's just going to run. No big deal. So what I want to do is I want to jump into cron.daily here. I'm going to take a look at this directory. And we are going to list what's in the directory. Let's go ahead and clear that first. Control L does that, or you can type clear. I'm old enough to remember typing clear. Some old terminals, the Control L didn't work. That's kind of a new thing. So what we're going to do is we're going to list what's in here. We're going to take a look at a couple of these scripts, and we're going to dissect them. We're going to tear them apart. We're going to figure out how this runs. We're going to kind of back engineer Anacron. So we see that there's a bunch of scripts in here. Apparently these are supposed to run daily. The first one is the Anacron script itself. So let's start there and see what we get. Now I'm going to use more, which is an old pager, to look at what's in Anacron. There we go. And this is what's in that script. So you notice that our shebang is a little bit different. It is calling sh. And we're going to dissect this entire shebang here in just a few moments and tell you what it's actually doing. sh is the old shell, the original shell. And they tell you when you learn about scripting that you should call for sh if you want universal compatibility with all Unix and Linux systems. So this Anacron script is ancient, and I can show you why it's ancient as we get down into it. And then in the comments here, it talks about what this script does, and it even explains why it starts with a 0, because that way it executes first when you run this, and it keeps this script. What it is doing is it is keeping track of when it runs. So the first thing that we're going to do here in the script after the comments is we're going to test. This is an ancient if statement. So you may be familiar with if statements, and this is how it was done years ago. So we're going to test, and we're going to look to see if this exists. If we have a command, user sbin Anacron, then go ahead and finish doing the script. If this is not there, this is going to exit with an error. And if it does, then what these double pipes do is it tells the system that if there are errors in the command in front of it, we want to do this. So we're going to exit with an error, but then we are going to exit the script, and we're going to set the error code to 0. I've noticed that a lot of these scripts do that. I'm not exactly sure why. But we'll take a look at how that works here shortly. And then, assuming that it passes this test and this exists, we're going to run the Anacron command, and it's going to run cron daily. Script done, and it exits and it moves on to the next thing. You notice there's no exit at the end of this script. So this basically is very interesting coding here, because we would create an error, but we don't want the system to exit with an error, so we use exit and we force the arrow code to be 0. We'll jump into that shortly, and I'll talk about how all that works. Right now, let's start with this bin sh up here, this particular shebang. And what we're going to do first is we're going to kind of blow this up. And I'm going to list what is in the root directory. And you're going to see that we have bin here listed. It's the first thing. And this is a directory, or it was a directory, in Linux systems where system binaries were stored. And these were usually things that were used by the administrator or the system itself. But you're kind of noticing that it's a different color. So if we do this again, and we do the long option, and we scroll back up here, you're going to see that bin doesn't actually exist here. Bin is a symlink. A symlink points to another directory, and this symlink is pointing to usr/bin. USR is user. I've also heard it referred to as Unix system resources. I don't know whether that one is apocryphal or not, but it is kind of cool, and it helps you to remember what's going on here, because this is where the systems, all the programs you install, this is where all the stuff goes. You'll also notice we have a lot of other links here, like lib goes to user/lib, and lib64 goes to user/lib64. And we have all of this. There's another one. sbin goes to user/sbin. I guess about 10 years ago, there was the beginnings of this push to stop having these individual directories in the system and throw them all into user/bin. But they have left the links in here, so it is backwardly compatible. This is why I was saying there are different ways that you could actually write your shebang. The other thing we want to look at is sh itself. So now I am going to, let's go ahead and change directories. We're going to get into user/bin and clear the screen. I want to ls everything that starts with sh and see if it's in here. Yeah, it's the first thing listed. Now, if I do that again, and this time I use the long option, you're going to find out something that might blow your mind a little bit. So I'm talking about calling sh in old scripts to make them super portable. Well, actually, we're not calling sh. We're calling bash. Hold on, I didn't do that right. Now you'll see it. Right here, up top. sh links to bash. So why are we writing our shebang that way? Shouldn't our shebang be written as pound exclamation point user/bin bash? No, do it this way. This is the way that Anacron expects your script to start, and I'm not terribly sure if it won't reject it if it doesn't. Anybody who knows better, you can put it down in the comments, but my advice to anybody writing a script for Anacron is to use this shebang. This is a universal shebang which should work on any Unix or Linux system, even though we're actually running in bash. So that was the first thing to talk about there. So let's take a look at another program, why don't we? Let's look at apport. So apport is an Ubuntu system program that clears old crash reports out, you know, those things that pop up on your screen and say this program unexpectedly stopped working. This is what it fixes. So if I go here and do more, and we'll go ahead and clear the screen, we'll get apport. And now we have a new twist on our shebang, which is a hyphen E there, like an argument. I believe that what that does is it tells the system to put the environment in a mode that if an error pops up, that it will simply stop the script and move on. There's another way to do that, which is a little bit more common. If I'm wrong about that, you can put it in the comments, but I believe that's what that does. So once again, we have our shebang here, and then we have another if statement written kind of in that same language. We are testing to see whether the directory user, or rather var/crash exists on the system. If it does, great, the script will continue to run. If it's not there, this will generate an exit code error, and then it will run exit with no error. So we're really trying to squash those error codes for some reason. I'm not quite sure why they're doing this. I looked this up, and according to all the documentation I read, it said that Anacron doesn't particularly care if something exits with an error. It does care if there's output from the command that runs, because that can cause a problem. We'll talk about that later. But it doesn't really care about errors. We're going to dive deeper into that when we start looking at writing scripts. So you're getting the idea of how this runs now. It's pretty simple stuff. So the next one that we want to look at would be, let's look at something a little bit more complicated. And I want to look at, let's ls again. Let's look at this apt compatibility script. Oops. So this starts with bin.sh for the shebang, and then we have the set e. I think that's the same thing as putting the e argument. Basically what this tells the system is, in this environment, while it is running, if there are any errors, dump out. Just stop. Then we have a real if statement here with the if and the phi and the whole deal. So this is more modern, apparently. So we have if, and then we test for a directory, and we're looking for run/systemd/system. If that exists, then we are going to exit without any error codes. If this does not exist, then the rest of the script will run, right? So that's what happens with an if statement. If it doesn't find this, it won't move on. It'll just continue running the script. So this basically makes it so that this will only run on a system that systemd is not running on. So technically speaking, this script has been deprecated, so we can do more. This is actually a long script. I'm not going to try and dissect that one, but just wanted to show you that. So I think we have enough now that we can look and see about writing our own scripts. Feel free to go onto your own system and look at these scripts. They are quite readable. They're open to anybody, and you can take a look at what's going on for yourself. So let's clear the screen, and I want to change directories, and I want to go to Documents. Wait a minute, hold on, it's not going to work. I need to tell it where my home directory is. So CD, we'll use the tilde, that's the abbreviation for your home directory. And then I want to go to Documents, because we're not in our home directory, that's why. And then we are going to look at scripts, because I want to be looking at my own scripts now. So we're going to ls, and we're going to look at anything that starts with a Z. Remember how I said Anacron would execute everything in the directory in alphabetical order? Well, anything that I added to it when I was fooling around with this myself, I started with Z to make sure it was the last thing that would run, just so all the system stuff would run in its normal order. I don't think that's going to, mess anything up, but you may want to do the same thing, or you may want to ignore that. Whatever works for you. So I have 4 of these scripts that we can play around with. This is stuff that I have written myself, and there are some things in here that I don't think you need. So let's start with zclean, which I think is the easiest one. And we'll dig into this here. And we're gonna take a deep dive into a lot of very deep scripting concepts, just so you understand what's going on. Here we go. So we're going to use nano to look at zclean. And we have a standard shebang, and we're using the sh for compatibility. Set E tells the system if there are any errors, dump immediately. This is a little description of what we're doing. And then we have this command. I'm going to work from the end of the command back. So the first thing we're going to look at here is where any output from this command is going. We're throwing it into the bit bucket. The reason why we're doing that is so that we do not generate any system mail. Most people who run Linux have no clue how to look for or look at system mail on their system. And if you have some process that's generating system mail and throwing it in there, it could build up. And anything that runs in cron or in Anacron, because it is a cron type service, is going to put its output into a mail which it's going to send to the user that ran it. In this case, it would be the root user. We don't want it to do that. So any output, we just want to get rid of it. And what this does here is it takes the output from the file and throws it into dev null. We talked about dev null in the last video. That's a place on the system where you can just take data and get rid of it. It just goes away. It doesn't go anywhere. It's gone. And then this little thing right here tells the shell that we want to take not only the regular output, standard out, from our command, but we want to take standard error, where error messages come out. They're two different channels. Throw them all into one and then throw them in the bit bucket. So that's what that does there. The command, it's pretty simple. apt-get auto clean. apt-get is an old program. These days it's been kind of taken over by the apt utility itself. But apt-get is still alive and well on Debian systems for backward compatibility. And the thing about apt-get is that it doesn't do any progress or anything like that. It just runs. So it's very lean and mean, so you use it in scripts a lot. And the auto clean, what that does is it goes and looks at your apt cache, which is where deb files get stored when you download them in case you need to reinstall. The system doesn't have to go out to the internet to get it. It's local, and it'll go much quicker that way. The only problem is that old files can build up there. There can be updates, for instance, and you have the old file on your system. If you're going to reinstall it anyway, it doesn't matter. You'd have to get a new one, and in that case, AutoClean will figure that out and dump those files and keep your apt cache from growing and taking up a bunch of space. And then we start this with the execute command, which we'll get into in just a moment. And then we have a completely, totally useless, superfluous exit at the end. Because we use the execute command, exit is never going to run. So let's start tearing this apart. Let's first talk about the execute command and what it does and why I put it in there. I'm not really sure why I did that back then, but it does a very interesting thing that you might find useful, especially for a script like this. Now remember, these scripts run. There's nothing wrong with them. It's just that you may not need to do this. But I'm going to show you anyway so that you understand what the execute command does. So let's clear the screen. And what I'm going to do is I'm going to use execute, and then I'm going to have it list what's on the system. And we'll even do long. Let's see what happens. Well, we saw it blip up there real quick. Did you see that? We saw the output, and then the whole terminal closed. Well, why did that happen? That happened because I ran the execute command. The execute command prevents the system from multitasking. What it does is it runs whatever command you feed to it in the environment you're already in. So if I run it, let's see, the best way to demonstrate this would be to run the command in another environment. Actually, there's a couple of ways to do this. Let's see what it's doing first, and we're going to do that by running execute, the execute command, and then we're going to do our ls again, and we're going to do our long listing, and I'm going to direct the standard output from this into a file which we are going to call ls out. So it's going to take any output from that and it's going to throw it in this file, and when that's done it'll exit. So watch. Now it disappeared again, right? But if we go back in here, and by the way, I'm using Control Shift and the plus key to make it bigger, and the Control and minus makes your terminal smaller. People always ask, so I always say how I'm doing that. So let's go ahead and make that where everybody can see. What I want to do is we'll use cat to look at that ls output file. See what's in it. Well, there's our listing. So the command ran, but why did it close the terminal? Because it didn't multitask. It ran it within the same environment. That command took complete control over our shell, and when it was done, it exited, and it exited our shell with it. See, when you launch a command, what the default thing that Unix or Linux does is it creates another environment for that to run in, a whole new shell. And when that's done, it exits that shell and it comes back to the one you're in. That's why we can have so many things running at the same time. We just create another environment. So what we need to do is manually create another environment. We're just going to run bash. If we do that, we get another environment. I know you can't see that right now, but I'll prove it to you, because if I exit, look what happens here. I go back. I didn't close the terminal. It didn't go away. I just went back to where I was. So once again, let's run bash. Okay. And we're going to open up a new environment. And this time we're going to execute. Well, not the whole word, just exec. And we're going to do the same command again. Now watch what happens. Now we see the output. We see the output because it was printed to the screen as the shell closed. So what you're seeing is it runs, it shows us the output, and then it closes the shell, and we went back to the one we were in before. I know there are a few of you out there who have smoke coming out of your ears right now trying to understand that concept, but that is the easiest way that I can show you how it works. Now the next thing I want to talk about is exit codes, error codes for exit, because I can really demonstrate how that works here. It's super easy to do. So let's clear the screen, and I will show you where that is stored. It is in a variable called $? Question mark. And the last command that ran had no errors, so that variable, and this is a system-wide variable, is set to 0. That means the last thing I ran didn't have any errors. So let's set an error. Let's make that happen. We can do it a couple of ways here. First, let's run ls. We'll look for something that isn't there. We're going to look for flark. There's no file or directory called flark, so we get an error on the screen. So that is standard error output right there, saying, sorry, couldn't find it. So let's check our error code by looking at what's in the variable. Now we got a 2. We got error number 2. Programs can set error numbers on their output. So if it's a really large program, it might set an error like error 255, and then you would be able to look up in the documentation. Well, an error 255 is whatever it is. Okay, that's how that works. So there's another way that I can create errors. I can do it manually, and we're going to do bash, open up another environment again. And now we are going to exit, but I'm going to give it a number. Let's do 255. So we exited. Now we're back in our original environment. And if we look here, we set that variable at 255. That's how this works. So having the exit command after this, since when it runs execute, it's going to do it in this shell that we spun up for this script, this is never going to run. It doesn't need to be there at all. That's why none of these scripts end that way. Does it matter? No, it's just extra text. But when you're writing scripts that are going to run in this environment, if you should happen to want to use execute for some reason so we're not generating another process to run, which makes it super efficient, then don't put exit. Do you have to do this? I don't think so. But feel free to experiment with it. So that's one of my files. And that one is one that actually runs on all my Linux systems. I usually throw it into cron monthly, so once a month it'll go through and clean out that cache. You could also do that with auto remove, which would actually uninstall things from the system that you don't need to have installed anymore. But that can be a bit dangerous and it might break something, so you might not want that running in the background. This is innocuous and it really doesn't matter. So what else do we have to look at here? Let's take a look at another one of these things. Let's do CYA, which is the Anacron script for a program that I helped to do beta testing on. It was written by a fellow named Jeremy O'Connell, and we worked on it together. He wrote all the code. I just tested it out and made suggestions. And this program was sort of like it still exists. You can go download it from GitHub if you want to. It is a pure terminal version of what Timeshift does. We've already talked about Timeshift. And so let's take a look at this file and see what it does. Well, everything's the same until we get down here. And I'm doing that execute one more time. And so it goes and it finds the program. And as it should, it lives in user local bin. The command is CYA. The argument is save, which means that it's going to create a snapshot. And then, of course, we take all of the output and throw it into dev null so it doesn't go into system mail. So where does system mail go? Well, I'll show you, kind of, sort of, because it's a bit of a mystery to me. And if anybody understands this, you can help me understand it, because I went and looked it up and I still didn't know what the hell was going on. So let's skip over here to our other terminal. We're going to clear the screen. And we're going to change directories, and we're going to go into var, which is variable. And this is an old Unix/Linux directory. It's on every system. And then we're going to look in the spool, which is another old Linux directory. And variable is for variable content. The spool is where raw things go that are going to be processed by programs. So for instance, it'll throw mail in here. And we can, let's go ahead and list that. We'll use the long option. So you see that we have Anacron, cron. Remember I told you that they generate certain output that goes into var. There's cups, that's the printing system. LibreOffice, everybody knows what that is. rsync log goes in here too. And then we have mail, which is actually a link to mail in the directory above. So you're getting the idea. This is how this works. Let's take a look at a couple of other scripts that I have written. Let's take a look at zdefrag, just to see what that does. All right, same deal as before. This runs the E4 defrag, and it's going to defrag the home partition right there and the root partition. So root and then home. And of course, any output we're not going to see. This would be useful if you did it about once a month and you had a very busy server with spinning drives. It's the only reason I can think of actually using this. These days, of course, we're all running SSDs. And running a defrag program on an SSD is frowned upon. Usually they say that it's just wasted write cycles because it really doesn't matter where the data is on the SSD. The access time is all the same. However, there are those who advocate for running defrag on an SSD like once a year, just so that you make all the files contiguous. And apparently that helps with the efficiency of storage for the drive. You can debate that in the comments. My personal opinion is that with the ext4 file system, you never have to defrag anything. The only time that defrag is really useful is if you're creating very large files. If you have big video files and they're kind of scattered all over a big drive, you may want to put that in one contiguous space. Also, if you're installing a system and you're creating a file which will become a swap file, you can run E4 defrag on it to make that contiguous, just to make it neater as you add other things to the system. So it's very useful because you can tell it to defrag an individual file if you want to. So it's pretty much the same format, and the exit at the end, of course, is superfluous. You're getting the idea. Let's look at one more here. And this is one I think people could actually use. And we're going to look at zbackup. I don't use it, but it would be a way to create a local online backup of things on a regular basis. You might want to run this like once a week, just to make sure that you have 2 copies of things. Now, if this is a drive that's always hooked up to the system, then this isn't really technically a super safe backup. This is a temporary backup. A true backup is on an offline drive, like a USB drive or something like that, or even if you send it through the internet over to some cloud storage of some sort. That is a much better backup than anything connected to your computer, because if the computer dies, right, it just goes poof, it might take that drive with it and you lose everything. So if you're using that as your exclusive backup, that's not a good idea. We have more action here, you'll notice. So there's a couple of things to look at here. We have the same shebang, and this is an Anacron script to run a daily local backup. Like, you could use it weekly if you wanted to, or monthly, whatever. And then the first thing that we're going to do is we're going to remove a file in this directory backup. So what we're assuming here is that you have a hard drive which is permanently mounted to the system in a directory called backup, and that the permissions are set so everybody has access to it. And so then we're going to look for any file named last here, and we're going to get rid of it. Once again, if there are any errors or problems, we're dumping all of the output so it doesn't go into system mail. The next command would be to create a flag file to tell us when the last time this particular script ran. This is the easiest way to log actions on the system I know of. And it takes up no space because what we're creating is an empty file. All right? There's nothing in here. It's not going to grow like a log file. Usually with a log file, we're adding some output line by line to it, and it gets bigger and bigger and bigger. And then you have to figure out how to manage that and all that stuff. This is super easy. If all you need to know is the status of the last time it ran, this will tell you. So we are looking here, and we're going to create a log, or a flag file rather, that says last backup run automatically, and we take the output from the date command right there, throw it in that variable, and then when the system reads that, it's going to take whatever the date command does, and it's going to put it in our title, and it's going to go in that directory. And now we also, once again, don't want any output there in case there's an error. Now we actually run the command. So we're going to execute it, which means we're not starting another environment. We're going to rsync, and these are the rsync options. Now, some of you who are very, very familiar with how rsync works are now looking at this and you're giggling because you see that I did something kind of stupid here. Useless. Have you figured it out yet? Right here, progress. That does not need to be there at all. Why? Because we're taking all the output and we're throwing it away. We're putting it in the bit bucket. We're throwing it into dev-null. Bye-bye, it's gone. So why would I have the program show me the progress? In other words, if you put this option in here, it shows you what it's doing with every file as it does it. Duh, that's pretty stupid. You might not be familiar with this. This limits the bandwidth of rsync. This is very useful for doing things over a network or to a slow drive. Like in this case, it might be a spinning drive. And so what will happen is if you don't limit the bandwidth, then your internet performance or your performance on your drives just goes to hell while this thing is copying these really long, great big files, virtual machine files or whatever they are. So this way, since this is running in the background, if you limit it, it's not going to take up all your system resources. And I believe this is kilobits per second. I think. I'm not really sure. I'd have to go look up the actual... I'd go look up the manual for this to see what that is. And so we grab the etc directory where all of our settings are, and we grab home, and we grab backup, and we throw it all in there. So there you go. So that's how that works. You can take this knowledge and go forth and write Anacron scripts and see if they work for you. I would suggest that you remember two things. Use this prompt, because I think I tried it years ago with Bash and it didn't like it. They may have changed that now, but still. And the other thing is to remember that all of this is running as the root user. You're not running as yourself. There is a way to create a script where you switch user and run as yourself, but that's kind of beyond the scope of this video, so we're not going to get into that today. One more thing I wanted to show you. I want to go back over here to our var directory, and I'd like to show you how Anacron keeps up with the last time it ran. You may be curious how it knows that it didn't run, and it goes and it checks that. Well, it's actually really, really super simple, as it usually is with programs like this. So we're going to jump back into our spool. Not pool, spool. Forgot the S. Hey man, we're going to CD into the pool. You want to come with us? Wow. All right. Why am I? Oh, that's right. I'm not in the right place to do that. I got confused. So let us, we'll do an absolute. When in doubt, do an absolute path. Don't try and figure out the relative. If you know what you're looking for, just do it this way, and then you'll go directly into it. So here we go. There we go. That's where we need to be. We're going to list it again. You see we have this directory in here, Anacron. So we're going to jump into that. We're going to jump into the Anacron directory, and we're going to list what's in here. And you'll see that we have 3 files, because remember, we have daily, monthly, and weekly. It is set up, right? So what is in these files? Now, these things are really locked down. So if we do ls and do a long here, you'll see that only root can read and write these files. I don't have permission to do that. But if I do it as root, we should be able to read what's in there. So we're going to sudo cat, and we'll start with, let's do them all. Cron, all right. We've got cron daily. So the first one will be cron daily. You remember that. And then we're going to do cron weekly. So we're going to do weekly next. And then we're going to do cron monthly. And what cat is going to do, it's going to read all of the stuff in that file. It's going to print it on the screen, one after the other, to see what it is. They're dates. That's what's in there. This is the last time that Anacron ran the daily, weekly, and monthly scripts. That's how it keeps up. So when it runs again, it'll go and check in those files to see when the last date was. It'll do the math and it'll figure it out. Pretty cool, huh? It's a super simple system, but it's extremely reliable. And let's take a look at Timeshift before we get out of here, just to show how that works with cron. It creates a cron job which tells the program itself to go look for something. So let's go check that out right now. And we need to open up Timeshift. We're going to look at it graphically. You can access some things about Timeshift from a terminal, but if you want to set it up, you have to do it graphically. It's a bit of a beef I have with the program, and it's part of the reason why Jeremy and I wanted to come up with something that ran completely from the terminal called CYA. So we're going to look in the settings here. Essentially, it does what I told you it would do. It goes and it creates a backup of the system. And let's say that I screw something up or delete something somewhere. I have no idea what's going on. Now, this does not apply to my home directory, my own personal files. This applies to the system itself. So if I say, okay, well, I want to roll back to this day, and I click restore, then it will go back, and anything that's changed since then will go away, and it will restore it, and it'll reboot the system, and then I'll be back to where I was. Assuming that, like if I installed a bunch of software and it didn't work and I wanted to get rid of it, or it crashed the system, or if you install video drivers that mess things up, as long as you can get to a command line, you can restore using Timeshift and go back. Now, this does not apply to stuff in your home directory. As I said, ordinarily when Timeshift is set up, it's going to ignore what's in the user's home directories. You can turn that on if you're on some system that has very little data in it, and for whatever reason you want to keep a running backup. But if you have a real system with, like a whole bunch of data in it, then as this thing collects snapshots and changes, it can take up a lot of space. It's once again not a very efficient backup, but there are people who use it this way because you can do it with a separate drive, and I just use it in the most basic way possible, which is as a system restore function. So let's go and look at the settings here. And what I want to show you is schedule. And we have it set up to run, it runs weekly, and then it creates a snapshot, and it keeps 2 of those snapshots. So that means that we always have a snapshot on the system that's 2 weeks old. So if we really don't know if our problem showed up in the last 3 days, we can go back to our last weekly or the one before that and restore the system. And then we do 3 dailies, and so that leaves us with a total number of snapshot backups of 5, which seems to be a reasonable amount. Now, every time it does a backup, it doesn't copy everything over. Actually, what it creates is a giant link farm, so it doesn't take up as much space as you think it would, but you still have to kind of keep that in mind. One of the things that we need to notice down here is, look here, it says you want to set the system so it does not send cron emails. Once again, we don't want to generate system mail, so that is how that works. Thank you for watching the video. I hope this helped you. We took a real deep dive. You have all of the information that you will ever need to use Anacron at this point, and feel free to play around with it. The sky's the limit. Anything that you want to automate and have run in the background that will make your Linux life easier, you can do. And it's very cool indeed. I'm looking forward to your comments and suggestions. Your suggestions give me ideas for new videos, and that's always nice to kind of know where we're going with a video. This one, as I said at the beginning, was a suggestion from a viewer. And this is actually a retake from the original video because I did the whole video and then I realized there were some things that I left out, and like how to write a script, and I realized that somebody who didn't know how to write scripts might want to take the couple of minutes to get some idea of how that works before we got into doing Anacron. But so this is actually a retake. I wanted to make sure I really covered this well, because I'm going to delete the original video from 2017. I don't think it needs to be in there anymore, because this will serve as my statement on Anacron. And thank you for watching it, and we'll do this again soon.